Hi, in this video, we will be looking at sequence properties and limits of sequences. We are going to look at two sequences, see whether or not they satisfy the properties of monotonicity, boundedness, and convergence. And if a sequence is convergent, we want to know to what does it converge. So I am looking at a sequence here, 3, that's minus 1 to the n times n, over n squared plus 2. And there are some initial observations that we would like to make. One of them is that this sequence is a alternating sequence where the minus 1 to the n changes signs depending on whether or not n is positive or negative. The other thing worth noting is that the sequence itself is bounded between the positive versions of these values and the negative versions of these values. So we note that 3n over n squared plus 2 by itself is non-negative, right? When n is 0, this expression is 0, and for every other n, this is a positive value. And consequently, this starts at 0 and the remainder of its values are negative. And the last thing to note is that this sequence here is convergent to 0. Right? We could see that through L'Hopital's rule. We can also see that by noting the quadratic dominates the linear numerator, and consequently this is convergent to 0 as well. And so all of these things put together should give us enough information to be able to answer these questions. The first of these is that this sequence alternates, right? It starts at 0 and then it goes negative, positive, negative, positive, negative, positive. Every time you go from negative to positive, you increase. Every time you go from positive to negative, you decrease. So as an alternating sequence, it is not monotonic. So that is our first observation. Since this series alternates, it is not monotonic. Now, the second observation that we want to note is that the sequence itself is bounded by two sequences. Those sequences are themselves bounded because they're convergent. And so this sequence has to be bounded as well. It has to be bounded by whatever this sequence's upper bound is and whatever this sequence's upper bound is. If we just plot the values of the sequence, we could see that it starts at 0, goes negative, positive, and so on. But both the upper and lower version of the sequences are bounded, so the sequence overall is bounded. And a quick observation here shows that this sequence is bounded by -1 and 1. Of course, you don't necessarily have to use those bounds to show that it's bounded, or even know what the bounds are. The very last part of this is to see whether or not this is convergent. It certainly appears to be convergent by plotting the values, but we can be a little bit more specific than that. It is bounded between two sequences with both converge to the same value of 0. So we can happily say by the squeeze theorem, this sequence converges to 0. All right. Now let's take a look at the second of our two sequences, the sequence 3n cubed over n squared plus 5. The first thing we want to note here is that this is a cubic over a quadratic. And because it's a cubic over a quadratic, its behavior is going to mimic a linear sequence. And in particular, it should, in the long term, mimic the behavior of 3n, comparing the leading terms of our rational sequence. And 3n, as we know, is not a bounded sequence, and so neither should this. We can be a little bit more particular than that, and we are going to use one of our favorite mathematical tricks, which is adding by 0. So something we want to note is that a sub n is equal to, well, of course, 3n cubed over n squared plus 5. But that itself is equal to 3n cubed plus 15n minus 15n over n squared plus 5. Now, why in the world would we want to do that? We could rewrite this as 3n cubed plus 15n over n squared plus 5 minus 15n over n squared plus 5. And this, on the left hand, on the left, we recognize as being simply 3n minus and then 15n over n squared plus 5. Now, it's worth noting every time I increment n by 1, this expression here increases by 3. This expression here decreases, but it can't decrease by 3. Its values are simply too small to be able to do that. And so we should note that this is this sequence is monotonic, not bounded, and not convergent. And if we wanted to see that, we could see the values here. We would have to resize our window to be able to see these values properly. Let's go with 3500 here. And we could see that in aggregate, the behavior of this sequence is almost identical to the line 3n, which we observed here. All right. Thank you very much. I'll see you in the next video.